Hello everyone. So today we have a question from JEE Advanced 2025, and this one is a classical beautiful problem involving drag force in projectile. Now normally projectile questions are a little trickier, but they never included drag so far in JEE Advanced, but here they have included it. Let's read the question and let's solve it in the minimum possible time. So we have a projectile of mass 200 grams. It is launched in a viscous medium at an angle 60 degrees. So let's draw the diagram as we speak. There is a body which is launched at an angle of 60 degrees, has a mass of 200 grams and initial velocity 270 meters per second. So this velocity here is 270 meters per second and it experiences a viscous drag force. Drag force is minus CV, where the drag coefficient is C, which is given as 0.1, and V is the velocity. Now this projectile hits a vertical wall after 2 seconds. Taking E to be 2.7, find the horizontal distance of the wall from the point of projection. So this projectile is moving in the air. It hits this vertical wall after 2 seconds. Now mind it, this point is not the highest point of the projectile. And we are asked to find this distance. Now normally when we have a question of projectile motion with drag, it is a lengthy process to find the equation of trajectory. And if you try to do that, it is going to waste a lot of your time. So if we look closely, and this is where you have to save time, there is no mention of height, no mention of any y coordinates in the problems. Which means that all we have to deal here is with the x coordinate, and that is precisely what makes this problem a lot easier than it appears. So we are given the time and we are asked to find the x coordinate of the projectile. So the first step, the obvious step, would be to draw the FBD of this projectile at any given time t. So if the velocity of this projectile is v, it will experience a drag force which is directly opposite to the velocity and given by CV. So this is the force. Of course, there is an mg also here, but since it is in the y direction, we don't bother about that. Let this angle here be equal to theta, which means this angle will also be equal to theta. And if I write the x coordinate, see, I don't have to worry about the y coordinate, no. So if I write the x coordinate of force acting on the body, it is just the horizontal component of drag. There is no other force. So minus CV cos theta. And interestingly, V cos theta is nothing but velocity's x component. And how do we write Fx? F is equal to ma. A is dv by dt. So Fx is dvx by dt. That is minus c times Vx. This is a very, very intuitive integration in Vx. So when I take this Vx down, I have this minus c by m times dt. Right? So 50% problem is done here. The limits, when the time is 0, when the body is projected, let the x component be some Vx naught. We'll put the values later on. And when the time is t, let the velocity x component be some Vx. Now this is a standard integral dx upon x is log x, and log upper limit minus log lower limit is simply log upper limit upon lower limit. Right hand side simply minus c by m times t. Log gets out, exponential comes. So I have an intermediate equation, Vx equal to Vx naught e raised to power minus c by m times t. This is the first equation that we have obtained. Now, if you look at this equation closely, already we are given time as 2 seconds. C is given to us and m is given to us and Vx naught we know. So if I were to find the velocity's x component at 2 seconds, I would have needed only this equation. But no, I have to find the x coordinate, the horizontal distance of the wall from the body. So what do? We write this Vx itself as dx by dt. Right? So I integrate acceleration, I get velocity. I integrate velocity, I'll get the x coordinate equal to Vx naught e raised to power minus c by m times t. And as dt goes up, after this, it's basic mathematics. And then we integrate. This time, when the time is 0, that is at the launch point, the x coordinate is 0. And when the time is, let's say the time is t, the x coordinate is some x. So integration of dx becomes x, and here I have the integration of minus e raised to power minus c by mt. In integration, this thing gets divided from 0 to t. Here the limits are 0 to x, which eventually gives you the x coordinate. If I manipulate this thing, m goes up, c goes down. Take this minus into account. I'll put the lower limit first. So when you put t equal to 0, e raised to power 0 becomes 1. The other limit becomes this. Guys, the problem is effectively solved. The x coordinate is a function of time, and this is precisely what is asked. Now, if you look at the mass of the body is 200 grams and c here is 0.1. So you put mass 0.2 kg, c 0.1, initial velocity 270, x component cos 60 half, c 0.1, m 0.2, time is 2. This whole thing becomes 270 times 1 minus, if you look at this also goes, e raised to power minus 1 is 1 by e. E is given as 2.7, so 2.7 minus 1, 1.7 upon 2.7. The answer is roughly 170 meters. That's how you do it. That is the x coordinate. That is the horizontal distance of the body from the wall. And if you look at the entire solution, it appears a little lengthier, but from JEE Advanced perspective, it's not that lengthy. There are quite a few steps that most of you people can even do in your head. So this distance we were required to find, y completely ignored, and we get the answer. That's it. Thank you.